This is a typical scene of whale watching in Iceland. This is a humpback whale going for a dive, showing its fluke, and people on the boat being very excited about it. And I was curious what this humpback whale is going to hear when it dives below the surface, if it's going to hear maybe the vessel or the waves on the water, or maybe some whales in the area. And so this is also what I'll be talking about today, about whale calls, about vessel noise, and what this has to do with the COVID pandemic. And I'm very excited to be here to present on behalf of my co-authors a recent study that we've just published. And I'm very thankful for the Hebridean Whale and Dolphin Trust to let me present this here today to you. If I'm saying we, I'll start with our story. We are the team of Whalewise. This is a charity based in the UK. We're currently doing most of our fieldwork in Iceland. We started this in 2018, and we're really trying to conserve the whales through research and engagement. And part of the team for this study is the co-director of Whalewise, Tom, and myself. We're both part of Whalewise, but also the rest of the Whalewise team has contributed to this significantly. And then this would have not been possible without my supervisor, Dr. Michelle Fernay from the Cornell University. She's now at UNH, but at the time she was at Cornell, and she really is the brain about the acoustics behind everything. And then we were joined by Dr. Marianne Rasmussen, Dr. Adam Smith, and Ollie Louisa that helped us a lot with equipment and additional support. So the study that I'm presenting today is based on those people. And now I'll really talk about the research rather. So in this study, we were looking at humpback whales. And I guess most of you know them anyway, since you're probably all whale lovers, but I'll give you a brief introduction anyway. Humpback whales are globally distributed. They really exist nearly everywhere on the planet. And they're known to migrate between breeding and feeding areas. So they're breeding in the tropics usually, and then they're feeding in colder waters of the polar region. And Iceland is one of those regions, and I'll talk about Iceland in a second more. And here, for example, you see two humpback whales lunge feeding and some Arctic terns around them. So this is very typical. They're also very famous for their vocal activity. The males are singing songs in especially the breeding areas, and this is really only the males that do that. But both sexes produce calls, so-called non-song vocalizations, much shorter and much quieter than song, and all around their migration route. So they do that also in the feeding areas. And then they also produce percussive sounds when they, for example, slap on the surface or breach. And since they make a lot of vocalizations, this is also very crucial for their life functions. It's really difficult to see underwater. It's much easier to communicate using sound. And like most animals of the ocean, also humpback whales rely on sound. And therefore, it's not surprising that they're quite sensitive to noise. The ocean is usually has sound anyway, like waves or rain make noise, other animals make noise. But recently, also humans are contributing to noise. And whales have shown, or humpback whales have shown reactions to that. For example, they change their calling rate, how often they call, or they change the amplitude. So they call louder, for example. They might also change their diving behavior and show surface or change their surface active behavior. For example, rather do percussive sounds compared to calls, perhaps to be just above and louder than the noise. And as I mentioned, humpback whales live all around the globe and also in Iceland. And this is where we're focusing our research up here in the north. This area is called Skjálfandi Bay. And in Skjálfandi Bay, there's Húsavík. They call themselves the whale watching capital of Europe. It's a very beautiful small town. And we've focused most of our research so far in that area, which makes sense because there you have many whales, but also many vessels, so a lot of anthropogenic activity. So when we zoom in a little bit, this is the bay, And you can imagine this bay in the summer months to be full of whales feeding and full of vessels, lots of whale watching vessels that want to see the whales, and even some cruise ships that visit the area. And now the question is, do the whales get disturbed by the noise of those vessels? And this is usually really difficult to study because you don't have a control. You don't have a time to compare it to when the whales behave the same way, but you don't have that noise because you wouldn't have vessels maybe at night, but whales behave differently at night anyway, or in winter, but you don't have the whales there, or at least they're behaving differently as well, or maybe during a storm, but then the noise is so different in a storm, you can't compare that either. So this is where COVID comes in. We were really lucky in this case, even though COVID also had obviously very many negative side effects, but it also was a great opportunity because the vessel traffic was reduced. So there were so much fewer vessels that we had a chance to compare a Skjálfandi Bay with few vessels to a Skjálfandi Bay with many vessels before COVID. And this is what we did to analyze the impact of vessel noise on the humpback whale calling behavior. So I'll introduce you to the datasets that we've gathered. Basically, it's 3 datasets. We have listened, we have watched, and we have tracked, and I show you how. So when we realized that opportunity, we deployed a hydrophone at this location, Fiskeskjær. It's called so because there's a rock that's called Fiskeskjær, Fish Rock, in the west of the bay. And our hydrophone looked like that. It's a sound trap. And the type of research that you do with such a hydrophone is basically a microphone underwater, and this is called passive acoustic monitoring. Acoustic because you listen to the sound, and passive because you don't make any noise yourself. You're really just listening, which is amazing because you don't have an impact yourself really. And this hydrophone was dropped from the side of a boat with an anchor, and it had a buoy to keep it upright. And then it recorded there for 2 months. So we could just have the full recording for 2 months. But the issue is when you come back after 2 months, you want to get your instrument, and it was at a depth of 50 meters. So you have to find a way to retrieve it. So we had an acoustic release attached between the anchor and the hydrophone, which is a cool piece of equipment. You can come back and send a signal from the surface, and it unties a screw at the bottom, and then everything floats back to the surface. So we got our hydrophone back 2 months later and downloaded the data, and we're really excited to see that it had worked. So this is what we had during the COVID pandemic. And then we were fortunate to get data from our colleague Adam Smith from 2 years prior from this location close to the island Flatey, so that we had something to compare it to before the pandemic when there was still full-scale whale watching going on. So we had 2 years of recording. But additionally, and that was from mid-June till mid-August, so really the two major summer whale watching months. But additionally to the hydrophones, we did some visual observations using a theodolite. So we spent quite a few days on the cliff on the western side of the bay, and we're looking for whales. Because the problem is the recording itself is useful, but it's not useful for every question. For example, if you want to know how often a whale is calling, this is really difficult. If you hear 10 whale calls in 1 hour, how do you know if it was 1 whale calling 10 times or 10 whales calling once each? So to answer such type of question, we spent the time on the cliff, and then we did scan samples. So 2 researchers were looking around the bay and find every whale within half an hour, and we marked the position of the whale using this theodolite. You can mark the location of the whale, and then we stopped for an hour, and then we did another survey, and we did that throughout the entire day to get some visual observations. And then the third data set that we use is AIS data, Automatic Identification System data, which is basically the GPS position of the vessel. They have to send that GPS position to the Icelandic Coast Guard every few minutes, and we got access to that data. And this is how it looks like, for example, for one day. So these are all the tracks of all whale watching vessels of the 28th of June. And we also don't only have that for whale watching vessels, we also have that for non-whale watching vessels. We could discriminate which are the whale watching vessels because we knew when they would leave the harbor, so we could find out which is which. When we got the data from the Coast Guard, this was just a number. Each vessel just had a number. So we just distinguished between whale watching and non-whale watching. So with these three data sets, we were able to answer the questions that we wanted. And our questions specifically were, how does Skjálfandi Bay sound like? What can you hear down there? Secondly, what changed during the COVID pandemic? And third, this is the original intention, do humpback whales change their calling behavior in the presence of vessel noise? And I'll go through these questions 1, 2, 3 and the results to those questions in the next 20 minutes. So how does Skjálfandi Bay sound like? Well, we were really excited when we found that the hydrophone was indeed recording. So we started listening to that. And that's the first thing that you do when you get a recording back. You just plug it into your computer, you put on your headphones, and you really start listening. And I'll show you some examples. We found that the sound of sharing, like the sound sharing of the computer might not work really well. So I'll play it to you, but also make the sound afterwards in case you weren't able to hear it quite well. So one thing that we heard very commonly is this. And for you that are less familiar with acoustics, this is a visual representation of sound. It's called a spectrogram. And people studying acoustics use this very often because it's very easy to look through a larger data set visually than if you have to listen to everything. And you can also see certain features very nicely. And this is basically time on the x-axis. In this case, we have a few seconds, and frequency on the y-axis, and color is loudness, intensity. So bright colors are louder, while darker and bluer colors are quieter. So on the bottom, you have loud and deep colors in this case. And here you have quieter but higher sound. And this is how this snippet sounds like. In case you weren't able to hear it, it's like, and this is a vessel, and we heard that quite a lot. Another thing that we heard is this, and I'll play it to you. It goes like, and this is a humpback whale, which is the second thing that we were looking for, which we were excited to hear. And this call is called a whoop call, and it's a very common sound that humpback whales produce. It's a contact call, or it's believed to be a contact call. The function isn't quite distinguished yet, but humpback whales produce that all over the world. But they don't only produce this type of sound, they also produce a million other types of sounds. For example, they might also sound like this. Which goes like something like that. So they're really variable, so it's really fun to listen to. But then we also heard other types of animals. For example, we also heard dolphins, and here they're whistling. Now this is really difficult to reproduce. It's like something like that. It's really high, not able to do it properly. So we really heard many nice things. But just listening to that obviously isn't science. So we wanted to understand the patterns of that soundscape, so of that, of the sound underwater. And for that, we plotted long-term spectral averages, which is basically the same like we've watched before. It's also a spectrogram, but what has changed is the time scale. So instead of seconds, we're looking at 2 months now. So this is the entire recording of 2018, 2 months, still frequency on the y-axis and color is loudness. And now you can start to see patterns. So you have bright patches. And we wanted to know what those bright patches are, so what the dominant drivers of sound are. And for that, we plotted environmental data. Here you have wind speed and precipitation, in this case rain, and surge, so wave height. And you can really see how well those bright patches in the higher frequencies align with storms. Here, for example, or here, you have really loud periods of time and lots of wind and lots of rain and lots of waves. So really this makes a lot of noise in that area and is a dominant driver of noise. But then there's a second pattern, and you might have seen this already, spotted it in the LTSA, long-term spectral average, and it's these patches down there. And I was really excited when I plotted this graph first, when I started counting them, because it's exactly 61. And you might have seen we recorded for exactly 61 days. So this is a daily pattern, and it's loud during the day and quiet during the night. And we went into the recording and checked out what the sounds were, and it's vessels. So really, the environmental sounds and vessels are both the dominant drivers of the noise in that area. So that was the start, understanding how Skjálfandi Bay sounds like. But additionally to those patterns, we wanted to know how loud it is in overall. So we basically got one sound pressure level, one value of loudness per day, and plotted that along the season. And you see on average, this is around 90 decibels. And this is very quiet. And that is really good news, because that area, even in a year that's full-scale whale watching, is relatively quiet. And this is really cool. So that was the second thing we wanted to know about the soundscape. Now here I'll also plot the 99th percentile and the 1st percentile, which basically means the loudest times of the day and the quietest times of the day, which by itself might not be that informative, but you'll see in a second that becomes interesting when we compare it to the second season. And this is what we'll get to now, the comparison. So what changed actually during the COVID pandemic? Well, let's look at this graph again. What we expected was that it would get quieter. So we did the same thing for 2020, and we plotted that, and we found that it actually didn't get much quieter. The green line on average is basically what the black arrow, the black line is here. And this is not significant. This difference is statistically not significant. It really didn't get much quieter, which is good news, because that means that the environmental drivers are probably more relevant than the vessels regarding the noise, because even with the reduction in vessels, it didn't get much quieter. But what you see is that the loudest times got quieter quite strongly, and this is significant. And we suggest that this might be that because there were no cruise ships, so no large vessels that are the loudest times of the day in 2018 just don't exist in 2020. And then interestingly, also the quietest times weren't as quiet. It was never just as quiet. And we don't really know why, but this might be because the location isn't exactly the same. So that might be an artifact of that. But really the average didn't get much quieter. But that doesn't matter for our other two questions. The next thing we wanted to know was, if we want to look at the humpback whale response to vessel noise, we first really need to know if there were less vessels, because maybe something weird happened in Skjálfandi Bay and all the vessels went out anyway. So we used our AIS data and we plotted that. And in this case, these are the whale watching vessels, and you have 2018 here and 2020 here, and you see how strongly that got reduced, how much less dense the spots here are. So, and when we quantified that, we saw that in 2018, on average, 42 trips, like vessels, went into the bay and back every day, while in 2020, only 13. So during those 2 months. So this was reduced to only 1/3 of the number of trips. So whale watching vessels or whale watching activities really decreased strongly in 2020. But if you compare that to the non-whale watching, this didn't really change. You see these are the non-whale watching vessels, and you can nicely see here this line going across, and then here this hotspot. This is fishing activities, and this might have even increased a little bit, but didn't really change much between the 2 years. But if you overlay both, the vessel traffic still decreased significantly. We also had the real numbers, and you can look them up in the paper. But this really was quite a reduction in vessel presence. And we were curious if we see that change in the amount of vessels also in a long-term spectral average, so also in the acoustic recordings that we had. So we plotted the same thing for 2020, and you can see that environmental drivers are relatively similar. Weather still influenced the bay. Obviously, that didn't get affected by COVID. But the vessel pattern is indeed less pronounced, especially in the beginning of the season. And this is interesting because also the vessel activities increased towards the end of the season, as you might have seen in that graph with the number of trips per day. And you see that in this vessel pattern as well. And then there's one nice side story that actually deviates from the rest of the talk, but I found it very interesting. There's this orange little stripe here. It's just a few seconds basically, and that was an earthquake. And I was really excited when I found it, because when we spent the time on the west of the bay for our visual observations, we had seen a landslide, not while it happened, but like the rest of the landslide. And then I found this in the recording, and I'll play it for you. It basically stops there anyway, and it's like, it's really, really, really loud. When I kind of had to take off my headphones when I first listened to it. It's really, really low frequency noise, and I got earthquake data from the Icelandic Meteorological Office and compared that to when this landslide happened, and it's exactly then. So, and we even used that type of data to time align our recordings, because we had some timestamp issues, so that was really helpful. And I found that very crazy how well you can hear that landslide, because it was very close to the hydrophone. Anyway, let's get back to our original question. Now it's playing again. There we go. So additionally to this trend where we saw that on the long-term spectral averages that vessel traffic decreased and that we also heard it less, we wanted to quantify that. And to do that, we took our data, and instead of looking at the entire continuous data set, we only looked at the first 4 minutes, because going through 2 months of continuous data is very tedious, and you need probably years to do that. So we only went through the first 4 minutes of every hour. So we had 24, we call this bins, so 24 samples every day. And we had 61 days, so approximately 1,500 bins. And we always looked at our spectrograms and listened to the data and annotated if we could hear a vessel or not. So we knew for which hour of which day we could hear vessels or we couldn't hear vessels. And so we could quantify how many vessels we could hear in 2018, how many vessels we could hear in 2020. And here you have the hours per day on average that you could hear a vessel. And in 2018, we could hear vessels approximately 15 out of 24 hours of the day. And in 2020, only 11. So quite a significant decrease. And overall, we heard vessels in 60% of the bins in 2018 and only 40 in 2020. So not just that the number of vessels got reduced, also the amount of time when vessels were audible, at least to us, at this location where we were recording, this also significantly decreased. And that was essential. Answering the second question, what changed during the pandemic, was essential to really use this time for our third question, which we'll get to now. If humpback whales really changed their calling behavior in the presence of the vessel noise. And to answer that, we did the same thing as we did for vessels for the whales. We went through the 4 minutes of the first 4 minutes of every hour and looked for humpback whales. And you've seen this before. This is the humpback whale call. And we annotated every time we found one. So we knew in which hours we could hear whales and in which we couldn't. And so this is the same thing as I've showed you for the boats just now. And you can see that we heard whales in 2018 only 5 hours of the day, while in 2020, 11. So much more than double. And we heard it 23% of the time, or 23.6, and in 2020, 45.9. So really about double, which is a lot more. And now the question is, why? And to answer that, we first plotted it by hour. So this is the average presence per hour. So this is the course of the day. And you see that we heard them a lot more in 2020 than in 2018, as I've just showed before, and that we heard them more at night compared to during the day. Now, we can plot the same thing for the vessels, for the vessel sound. And obviously, we heard vessels more during the day. That makes a lot of sense because the boats go out into the bay, usually during the day, especially whale watching, but also fishing in the morning and also during the day. Now, the question is, do humpback whales call less during the day because there are vessels? Or is that just a natural phenomenon? Do they just call more at night? I don't know, because they're feeding more at night, for example. And to answer that question, we built some fancy statistical model called a generalized linear model. And we included hour as a random effect. That basically means we looked at every hour individually. And we did that for both years. And we found for every hour individually, so independent of time of day, that the probability to detect a whale decreased with the number of whale watching vessels around our hydrophone. So the more vessels there were, the less likely it was to hear a whale independent of hours. So it wasn't just a natural trend that whales call more at night. This really was because of the vessels. Now, the question remains, did the whales change their behavior? Did they really call less? Or did we just hear them less? Because that's another thing that could be, because the vessels make noise, right? So it could be that we just couldn't detect the whales, even though they were calling the same amount of time. And for that, our visual observations came into play. Now they became essential. So these are the whales that we saw. And we decided to make a new data set, or a subset of the data, with only times where we knew whales were within 3 kilometers of our hydrophone, because within 3 kilometers, it's quite likely that you can hear the whale. So masking, being covered by the vessel sound, it wouldn't be an issue. And we also only included times under a certain loudness threshold, so that we would be very certain we would hear a whale if it's calling. And we know a whale is there, so really we would hear it. And we built another model, a logistic regression model. And we found that with the more whales there were, the more likely it was to detect one. That makes sense, right? If you have more whales, it's more likely to hear a whale call. And it's also more likely that they're calling because they might be communicating. But interestingly, when vessel sound was absent, it was much more likely to hear a whale than when vessel sound was present. So now finally, we could really conclude that the humpback whales changed their vocal behavior in the presence of vessels. They really call less. It's less likely to hear them when vessel sound was present. Okay, that was a lot. So I'll sum that up just to wrap it once around again. So we have Skjálfandi Bay, and we found that Skjálfandi Bay is very much dominated, the sounds in Skjálfandi Bay are dominated by environmental noise, such as waves or wind or rain. But we can also hear vessels quite well. They're the second dominant driver of noise. And we can also hear some animals, including humpback whales. They're calling there. And overall, it's very quiet. And then during the COVID pandemic, the vessel traffic was significantly reduced, especially whale watching vessels. And humpback whales were calling more. We could hear them more. And the reason why we heard them more is likely because the vessels make noise, and when they make noise, the humpback whales reduce the amount of calls that they make. And all of this is summarized in the paper that we've recently published called The Impact of Whale Watching Vessels on Humpback Whale Calling Behavior on an Icelandic Foraging Ground during the COVID-19 pandemic. And I can send the link maybe later in the chat that you guys can check that out if you want to read more details about it. So what does that mean? What do we want to do with that? We hope that this will have implications for the whale watching in the area. There are very many boats around one whale every summer, or around all the whales, and they all make the sound or the noise. And we really hope to implement what we find in our research into regulations, for example, that vessels might have to turn off their engine when they're around a whale, or that they might have to use only vessels that have a maximum loudness, or that they have to reduce their speed because, for example, the faster a vessel is, the louder it is. And so far, these are really just first results. We kind of intend to do more research to find out if really which part of the sound it is that is the problem, if it's like the loudness or just the presence itself and things like that. But it's a start, and we really hope that this will change maybe the whale watching activities a little bit to minimize the impact. So we are continuing our research. We had a hydrophone in the water again 2021 at the exact same location as 2020, which is really nice. This is funny because my PowerPoint keeps adding the next thing at this slide, and it did that during trials as well, and I don't know why. And the nice thing about that is that it's the exact same location. I'll have to click back and forth. Because the location wasn't quite the same in the study that I've showed you today, and that might have implications. I think it's still relevant what we found, because the results are true at each location, but still it would be really nice to compare the 2020 season with very little whale watching with 2021, where there was increasing whale watching again at the exact same spot. But we haven't looked at that data set yet. And then we also, and now I can go to that, did lots of behavioral observations with many years of field work. Tom, who's part of this study and co-director of WellWise, has done this as his PhD thesis, behavioral observations, as well as blow samples, where we collected the breath of the whale to look at physiological stress response due to whale watching, because the response wouldn't only be a response in calling, possibly. It might also be some other physiological response or behavioral response, and really you need to look at the full picture to see the impact of the whale watching. But acoustics is part of it, and this is the part that I've presented today. And therefore, I'd like to thank you for your attention now. I'd also like to thank all the people that have made this work possible, including the people from the Research Center, including Chala and Ali, our captain, and many people that have lended equipment and supported our work. The whale watching guides, where we were able to spend time on their boats, and all the people that have made this possible. And thank you for WhaleWise for being such an amazing team, and to the Hebridean Whale and Dolphin Trust again for letting me share our research here today. And now